Hello there, and welcome to Whispers of Science, where the universe's deepest mysteries get a gentle voice and cosmic wonder finds a cozy corner to unfold. Tonight, we're embarking on a journey to the edge of everything we know, where space and time bend so dramatically that reality itself seems to whisper secrets we're only just beginning to understand. I'm so glad you found your way here, whether you're settling in after a long day, curled up somewhere comfortable, or simply letting your mind wander toward the stars. This is our quiet little sanctuary where science becomes storytelling, where the most profound discoveries of our time are shared like bedtime tales from the cosmos itself. Tonight's voyage takes us to perhaps the most enigmatic objects in the universe: black holes. These aren't just cosmic vacuum cleaners, as they're often portrayed, nor are they simple tears in the fabric of space. There's something far more fascinating, far more mysterious, and dare I say, far more beautiful than most of us have ever imagined. We'll explore whether they might be portals to other realms, cosmic traps that devour everything, or perhaps most intriguingly, gateways to entirely new physics that could reshape our understanding of reality itself. Now, before we drift deeper into this celestial mystery, I'd love to know where in the world you're listening from tonight and what draws you to these cosmic questions. Are you gazing up at the stars right now, or are you somewhere cozy, letting your imagination travel where your body cannot? There's something rather poetic about contemplating the universe's most extreme objects while nestled safely in our earthly comforts, isn't there? If you find yourself enchanted by these whispered explorations of science, I'd be ever so grateful if you'd give this video a gentle like, perhaps subscribe to join our growing community of cosmic wanderers, or simply leave a comment sharing what fascinates you most about the mysteries we'll uncover together. These small gestures help our quiet corner of wonder reach others who might need a peaceful pause to contemplate the magnificent strangeness of existence. So take a deep breath, let your thoughts settle like stardust, and prepare to peer into the abyss that peers back into us. Because somewhere in the darkness, between what we know and what we dream, lies the story of black holes, and tonight we're going to whisper their secrets together. What exactly is a black hole? It's a question that sounds deceptively simple, like asking what water is or what makes the wind blow. But just as those seemingly basic queries open doors to fascinating complexity, black holes reveal themselves to be among the most profound and perplexing phenomena our universe has to offer. At its heart, a black hole is a region of space-time where gravity has become so intense that nothing, not even light itself, can escape once it crosses a certain boundary. Imagine, if you will, trying to throw a ball so hard that it never falls back down to Earth. You'd need to reach what physicists call the escape velocity, about 25,000 miles per hour. That's the speed required to break free from our planet's gravitational embrace. Now picture an object so massive and so compressed that its escape velocity exceeds the speed of light itself, 186,000 miles per second. Since nothing in our universe can travel faster than light, nothing can escape. It's as if the universe has created the ultimate cosmic prison, a place where the very fabric of reality becomes so warped that escape is not just unlikely, it's impossible. But here's where the story becomes truly captivating. Black holes aren't actually holes at all, despite their rather misleading name. They're more like cosmic sculptures carved from the raw material of space time itself. Einstein's general relativity teaches us that massive objects bend the space around them, like a bowling ball placed on a stretched rubber sheet. A black hole represents the extreme case where this bending becomes so severe that space and time curve back on themselves, creating what we might call a gravitational well so deep that its walls are vertical. The birth of a black hole is a story of stellar drama on the grandest possible scale. When certain stars, those at least 20 to 25 times more massive than our gentle sun, reach the end of their nuclear burning lifetime, they face a moment of cosmic reckoning. For millions of years, these stellar giants have maintained a delicate balance, their nuclear furnaces pushing outward against the relentless inward pull of their own gravity. But when the fuel runs out, when the last helium nucleus fuses into heavier elements, and no more energy can be squeezed from matter itself, gravity wins with sudden, devastating finality. The star's core collapses in less than a second, compressing matter to densities that boggle the mind. A region the size of a city suddenly contains more mass than our entire sun, creating gravitational fields so intense that they warp spacetime into something unrecognizable. The outer layers of the star, meanwhile, rebound off this impossibly dense core and explode outward in what we call a supernova, one of the most energetic events in the known universe. For a few weeks, this single exploding star can outshine an entire galaxy containing hundreds of billions of other stars. It's nature's way of announcing that something extraordinary has just been born from stellar death. What remains behind, hidden within the expanding shockwave and glowing debris, is a black hole. The core has collapsed beyond any point of return, beyond even the nuclear forces that hold atoms together, beyond the quantum pressures that keep matter from occupying the same space. It has become what physicists somewhat poetically call a singularity, a point where our current understanding of physics simply breaks down and whispers, "Here be dragons." This brings us to one of the most haunting and beautiful concepts in all of physics, the event horizon. Picture, if you can, an invisible sphere surrounding the black hole's center, marking the boundary between the possible and the impossible. Cross this threshold, and you've entered a realm where the normal rules of cause and effect begin to blur, where time itself stretches and warps in ways that would seem like magic if they weren't grounded in the most rigorous mathematics we possess. The event horizon isn't a physical surface like the ground beneath your feet or the walls of your room. You couldn't touch it or bounce a ball off it. Instead, it's more like a cosmic point of no return, a gravitational waterfall where space itself is falling inward faster than light can swim upstream. From the outside, it appears as a perfectly black sphere, earning these objects their rather ominous name. But here's where our story takes its first mysterious turn. While we call them black holes and imagine them as cosmic vacuum cleaners, indiscriminately devouring everything in their path, the reality is far more nuanced and, dare I say, elegant. Black holes aren't actually pulling any harder on distant objects than a normal star of the same mass would. If our sun were somehow magically replaced with a black hole of identical mass, Earth would continue orbiting exactly as it always has, though our days would certainly become rather chilly and dark. The danger zone, the region where black holes reveal their true power, exists only very close to the event horizon itself. At safe distances, they're simply another massive object in the cosmic dance, no more threatening than any other star. It's only when matter ventures too close that the story becomes dramatic, and what a drama it becomes. As gas, dust, or the occasional unfortunate star wanders within the black hole's sphere of influence, it doesn't simply fall straight in like a stone dropping down a well. Instead, it begins to spiral inward, forming what astronomers call an accretion disk. This cosmic whirlpool can stretch for millions of miles, a flat, spinning disk of matter gradually spiraling toward its doom. But this is no gentle descent. As material in the accretion disk orbits closer and closer to the black hole, it accelerates to tremendous speeds, sometimes reaching significant fractions of the speed of light itself. The friction between different layers of this spinning disk heats the matter to temperatures of millions or even billions of degrees, causing it to glow with such intensity that these feeding black holes become among the brightest objects in the universe. It's a beautiful irony that black holes, objects from which no light can escape, can create some of the most luminous beacons visible across cosmic distances. These quasars and active galactic nuclei, powered by supermassive black holes consuming vast quantities of matter, can be seen from billions of light years away, their brilliance serving as lighthouses in the deep ocean of space. Yet, for all their spectacular feeding displays, black holes remain fundamentally mysterious. They represent places where our most successful theories of physics, quantum mechanics, and general relativity seem to point toward contradictions that we don't yet know how to resolve. They're cosmic laboratories where the universe conducts experiments at the very limits of what's physically possible, and we're still trying to read the results. This tension between what we observe and what we can explain has led some of the brightest minds in physics to wonder whether black holes might be something even more extraordinary than we currently imagine. Perhaps they're not endpoints at all, but rather doorways, cosmic transit stations, connecting distant regions of space-time in ways that would make science fiction authors weep with envy. Or maybe they're nature's way of processing information itself, cosmic computers performing calculations we can barely comprehend using the fundamental code of reality. Some theorists have even suggested that what we perceive as three-dimensional reality might actually be a kind of holographic projection emerging from information encoded on the two-dimensional surface of black hole event horizons. These aren't just wild speculations born from too much coffee and too little sleep, though I suspect both have played their role in advancing our understanding. They emerge from serious attempts to reconcile what we see with what we know, to bridge the gap between observation and comprehension. As we stand at the threshold of these cosmic enigmas, peering into their mathematical depths and observational mysteries, we encounter perhaps the most profound question in modern astrophysics. What actually happens to information when it falls into a black hole? This isn't merely an academic puzzle for physicists to ponder over their morning tea. It strikes at the very heart of how reality operates at its most fundamental level. You see, one of the bedrock principles of quantum mechanics is that information cannot be destroyed. Think of it like this. If you burn a book, the information contained within those pages doesn't simply vanish into nothingness. In principle, if you could gather every ash particle, every photon of light emitted, every molecule of gas released, you could reconstruct the original text. The information becomes scrambled, yes, but it persists in some form throughout the universe. But black holes seem to violate this sacred rule. When matter crosses the event horizon and presumably reaches the singularity at the center, where does its information go? According to classical physics, it should be trapped forever, encoded somehow within the black hole's interior. Yet Stephen Hawking's revolutionary work in the 1970s revealed that black holes aren't perfectly black after all. They actually emit radiation, slowly evaporating over cosmic time scales. This Hawking radiation emerges from the quantum foam that permeates even empty space, where particle and antiparticle pairs constantly pop into existence and annihilate each other. Near a black hole's event horizon, sometimes one member of such a pair falls in while the other escapes, appearing to outside observers as radiation emerging from the black hole itself. It's as if the black hole is slowly dissolving, returning its mass to the universe as a gentle stream of particles. Here's where the mystery deepens into what physicists call the information paradox. If a black hole eventually evaporates completely through Hawking radiation, and if that radiation appears to be completely random and thermal, carrying no trace of the original information that fell in, then where did all that information go? Did it simply disappear, violating one of our most fundamental principles? Or is it somehow encoded in the radiation in ways we don't yet understand? This paradox has kept theoretical physicists awake for decades, spawning entire careers and filling countless journals with increasingly exotic proposals. Some suggest that the information somehow gets encoded on the black hole's event horizon, stored in a holographic form that we're only beginning to glimpse. Others propose that black holes might not destroy information at all, but rather scramble it so thoroughly that recovering it would require computational resources exceeding anything the universe could provide. Still others have ventured into even stranger territory, suggesting that black holes might be cosmic recycling centers, processing information and matter before sending it elsewhere through mechanisms we've barely begun to imagine. Perhaps the singularity at a black hole's center isn't an endpoint at all, but a transformation chamber where the normal rules of space-time break down and reform into something entirely new. This brings us to one of the most tantalizing possibilities in all of theoretical physics. The idea that black holes might serve as gateways to other regions of space-time, or even to entirely separate universes. The mathematics of general relativity has long hinted at such possibilities through solutions known as wormholes, hypothetical tunnels through the fabric of space-time that could connect distant regions of our universe or link to other universes entirely. Imagine, if you will, that what we perceive as a black hole from our perspective might appear as a white hole, a hypothetical opposite that spews matter and energy outward when viewed from the other side. The matter and energy that disappears into our black hole might emerge from a white hole in some distant corner of space-time, carrying with it all the information we thought was lost. It's a beautiful concept, reminiscent of cosmic plumbing, where the universe maintains its books balanced through an intricate network of connections we can barely perceive. Yet the challenges of creating and maintaining such wormholes are staggering. They would require exotic forms of matter with negative energy densities, materials that might not even be possible within the laws of physics as we understand them. Moreover, even if such wormholes could exist, they would likely be incredibly unstable, collapsing faster than anything could pass through them. It would be like trying to send a letter through a tunnel that closes the moment you drop the envelope in. Still, some physicists have proposed that advanced civilizations might somehow learn to stabilize these cosmic passages, using them as highways for travel across vast distances or even between different universes. The implications stretch far beyond science fiction. If black holes truly are gateways rather than dead ends, it would fundamentally alter our understanding of cosmic evolution itself. And instead of being cosmic graveyards where matter goes to die, they might be birthing chambers where the ingredients for new regions of space-time are processed and prepared for deployment. Consider the supermassive black holes that lurk at the centers of most galaxies, including our own Milky Way. These giants contain millions or even billions of times the mass of our Sun, and their influence shapes the evolution of entire galactic neighborhoods. If they're not just gravitational anchors, but active participants in some larger cosmic recycling program, then galaxies themselves might be far more dynamic and interconnected than we've ever imagined. Some cosmologists have even proposed that our entire universe might have emerged from the interior of a black hole in some parent universe, part of an infinite hierarchy of nested realities. In this view, every black hole in our universe might be giving birth to new universes, while our own cosmos exists within a black hole from the perspective of beings in the universe above us. It's a dizzying concept that stretches the imagination, yet it emerges naturally from serious attempts to understand the deepest implications of our current theories. If true, it would mean that what we call the Big Bang wasn't the beginning of everything, but simply our local beginning, the moment when our particular bubble of space-time separated from its parent and began expanding on its own. But let's step back from these cosmic speculations and consider what we can actually observe. In recent years, astronomical instruments have provided us with unprecedented views of black holes in action. The Event Horizon Telescope has captured actual images of the supermassive black holes at the centers of our galaxy and the galaxy M87, revealing the glowing accretion disks and the dark shadows that mark their event horizons. These images confirm many of our theoretical predictions while raising new questions. The black holes appear exactly as Einstein's equations suggested they should, with light bending around them in precisely the ways general relativity predicts. Yet the detailed structure of their accretion disks and the behavior of matter in their vicinity continue to surprise us with their complexity and beauty. Meanwhile, gravitational wave detectors have opened an entirely new window into black hole behavior, allowing us to eavesdrop on the cosmic collisions when two black holes spiral into each other and merge. These events, which occur somewhere in the observable universe, roughly once every few minutes, produce ripples in space-time itself that we can now detect and analyze. Each gravitational wave detection tells us a story about black holes we never could have learned through light alone. We discover black holes with masses we didn't expect in places we didn't predict, suggesting that our understanding of stellar evolution and black hole formation still has significant gaps to fill. These detections have revealed something remarkable about the nature of space-time itself. When two black holes merge, they don't simply add their masses together like cosmic accounting. Instead, they create something entirely new, a single black hole that weighs slightly less than the sum of its parts. That missing mass doesn't disappear. It converts directly into gravitational waves that ripple outward at the speed of light, carrying the energy of the collision to every corner of the universe. The amount of energy released in these mergers is staggering beyond comprehension. In the final moments, before two black holes unite, they can emit more power in gravitational waves than all the stars in the observable universe combined. For a brief instant, these colliding black holes become the most energetic events occurring anywhere, outshining entire clusters of galaxies in pure gravitational radiation. What's particularly fascinating is how these mergers might serve as cosmic laboratories for testing the very foundations of physics. As black holes spiral toward each other, they reach velocities approaching the speed of light while experiencing gravitational fields billions of times stronger than anything we can create on Earth. The space-time around them becomes so severely warped that it provides a natural testing ground for Einstein's most extreme predictions. Some physicists have begun to wonder whether these merger events might offer clues about black holes' true nature. Perhaps the gravitational waves carry encoded information about what happens deep within black hole interiors, or maybe they reveal signatures of connections between black holes and other regions of spacetime. Each detection adds another piece to a puzzle we're still learning how to assemble. But gravitational waves have revealed something even more intriguing about black holes themselves. The way these massive objects ring like cosmic bells after merging suggests they possess what physicists call no-hair theorem properties. According to this principle, black holes can be completely described by just three characteristics: their mass, their electric charge, and their spin. Everything else about their formation, their history, their composition gets erased, leaving behind the simplest possible objects that could exist at such extreme scales. Yet this apparent simplicity masks profound complexity. A spinning black hole, what physicists call a Kerr black hole, drags space-time around with it as it rotates, creating a region called the ergosphere where nothing can remain stationary relative to distant observers. Within this zone, space-time itself is rotating, pulled along by the black hole's spin like honey swirled by a cosmic spoon. This frame-dragging effect opens up possibilities that sound like pure science fiction. In principle, it might be possible to extract energy from a rotating black hole by dropping matter into the ergosphere and allowing the black hole's rotation to accelerate it before pulling it back out. The extracted matter would emerge with more energy than it went in with, having borrowed some of the black hole's rotational energy. It's a cosmic version of the flyby maneuvers spacecraft use to gain speed from planetary encounters, except the energy source is the rotation of spacetime itself. Some scientists have speculated that advanced civilizations might build vast machines around rotating black holes to harvest this energy, creating what physicist Freeman Dyson might have called black hole spheres. These hypothetical megastructures could tap into the rotational energy of supermassive black holes, providing power sources that could sustain galactic civilizations for billions of years. But perhaps the most mind bending aspect of black hole physics emerges when we consider what happens to time itself near these cosmic extremes. Einstein's relativity tells us that time runs slower in stronger gravitational fields, an effect called gravitational time dilation. Near a black hole, this effect becomes so extreme that it fundamentally changes the nature of causality itself. From the perspective of someone falling into a black hole, the journey toward the event horizon and beyond might take a finite amount of their personal time. They would experience crossing the boundary and continuing inward, assuming they could somehow survive the tidal forces that would normally tear apart any normal matter. But from the perspective of outside observers, something very different appears to happen. As the falling object approaches the event horizon, light from it becomes increasingly redshifted, stretched to longer and longer wavelengths by the black hole's immense gravity. Time dilation causes the falling object to appear to slow down from an outside perspective, its image becoming fainter and redder until it fades from view. To external observers, the object never quite seems to cross the event horizon at all, instead, appearing to freeze at the boundary and slowly fade away. This creates a fascinating paradox about the nature of black hole formation itself. If nothing ever appears to cross the event horizon from an outside perspective, how do black holes form in the first place? The resolution lies in understanding that different observers experience different versions of reality near black holes, each equally valid within their own reference frame. This leads us to one of the most profound questions in modern physics. What is the relationship between information, consciousness, and the structure of spacetime itself? Some physicists have begun to explore the possibility that consciousness might play a fundamental role in how we understand black hole physics, not in some mystical sense, but in terms of how information processing and observation affect the nature of physical reality. The holographic principle suggests that all the information contained within a volume of space might actually be encoded on its boundary. For black holes, this means that everything that ever fell into them might still exist in some form on the event horizon's surface, like a cosmic library where every book ever written is somehow stored in the thickness of its walls. This idea connects to some of the deepest questions in quantum mechanics about the role of measurement and observation in determining physical reality. If black holes are indeed cosmic information processors, then understanding their true nature might require us to develop new ways of thinking about the relationship between mind and matter, between the observer and the observed. Recent developments in quantum information theory have suggested that black holes might be connected to other black holes through quantum entanglement, creating what physicists call Einstein-Rosen bridges, or wormholes. These connections wouldn't allow for faster than light travel or communication, but they might represent a fundamental feature of how space-time is woven together at its deepest level. The mathematics behind these ideas involves concepts that push the boundaries of human comprehension. Black holes might exist in higher dimensional spaces that we can only perceive through their effects on our familiar three dimensions of space and one of time. String theory, one of our most ambitious attempts to unify all of physics, suggests that black holes might be manifestations of vibrating strings in dimensions we cannot directly experience. In this view, what we perceive as a black hole might be like the shadow of a higher dimensional object cast onto our four-dimensional spacetime. Just as a three-dimensional sphere casts a circular shadow on a two-dimensional surface, a higher dimensional black hole might cast the shadows we observe and call event horizons. These ideas lead to fascinating possibilities about the nature of reality itself. If our universe is indeed embedded in higher dimensional spaces, then black holes might serve as windows through which we can glimpse these hidden dimensions. The information that seems to disappear into black holes might not be lost at all, but rather translated into forms that exist in dimensions perpendicular to our own experience. Some physicists have even proposed that black holes might be fundamental building blocks of reality, cosmic seeds from which space and time themselves emerge. In this view, the Big Bang wasn't the beginning of everything, but rather the moment when our particular region of space-time separated from a parent black hole and began expanding on its own. This brings us full circle to questions about the ultimate fate of our universe. If black holes truly are gateways to new physics, then they might hold the keys to understanding not just how our cosmos began, but where it's heading. As our universe continues to expand and cool, black holes might eventually become the dominant features of reality, cosmic islands of intense gravity in an otherwise empty and dark expanse. But even this seemingly bleak future might contain hidden wonders. If black holes are indeed connected through quantum entanglement or higher dimensional bridges, then the far future might not be one of cosmic isolation, but rather of deep connection through mechanisms we're only beginning to imagine. The universe might transform from its current state of bright stars and active galaxies into something like a vast neural network, with black holes serving as nodes in a cosmic information processing system. Perhaps most intriguingly, some theorists have suggested that the information processing capabilities of black holes might eventually give rise to forms of consciousness that exist on cosmic scales and time scales. These hypothetical cosmic minds would experience reality in ways utterly foreign to biological consciousness, thinking thoughts that take millions of years to complete, and processing information encoded in the fabric of space-time itself. Such possibilities remind us that black holes, for all their apparent simplicity, continue to challenge our most basic assumptions about the nature of existence. They force us to confront questions about information, consciousness, time, and space that go far beyond conventional astronomy or physics. They are cosmic koans, riddles posed by the universe itself that might ultimately teach us as much about the nature of mind as they do about the nature of matter. As we continue to study these enigmatic objects, using increasingly sophisticated instruments and theoretical frameworks, we find ourselves standing at the threshold of discoveries that could fundamentally reshape our understanding of reality itself. Whether black holes prove to be cosmic trash compactors, interdimensional gateways, or something even stranger, they represent frontier territories where the known meets the unknowable, where science confronts mystery with wonder rather than fear. And perhaps that's the most beautiful aspect of black holes. They remind us that the universe still holds secrets worth discovering, mysteries that beckon us forward into territories of knowledge we've barely begun to explore. In their dark hearts lie answers to questions we haven't even learned to ask yet, whispered in the language of curved spacetime and quantum uncertainty. Suhi, tonight, as we venture deeper into the heart of these cosmic enigmas, we encounter what might be the most extraordinary aspect of black hole physics, their relationship with the very fabric of reality itself. You see, black holes don't simply exist within space time like objects sitting on a table. Instead, they fundamentally alter the nature of space and time around them, creating regions where the normal rules of existence become beautifully, mysteriously strange. Consider for a moment what happens to light itself as it ventures near a black hole's event horizon. Light, that fundamental messenger of information throughout the universe, begins to behave in ways that would seem magical if they weren't grounded in the most rigorous mathematical frameworks we possess. As photons struggle against the immense gravitational field, they lose energy, their wavelengths stretching like cosmic taffy being pulled by invisible hands. This phenomenon, called gravitational redshift, means that light emerging from near a black hole appears redder and dimmer to distant observers. But it's more than just a visual effect, it's a fundamental alteration of energy itself. The black hole isn't just bending light's path, it's reaching into the very essence of electromagnetic radiation and reshaping it according to the curvature of space-time. Now imagine you're watching a clock near a black hole's event horizon. From your safe distance, you would see something that challenges our most basic intuitions about time. The clock would appear to tick more and more slowly as it approaches the event horizon, each second stretching into minutes, then hours, then years from your perspective. Eventually, the final tick before crossing the event horizon would seem to take forever, the clock's hands frozen in an eternal, almost moment. Yet, from the perspective of the clock itself, time flows normally. This isn't a malfunction or an illusion. It's the universe revealing one of its most profound truths. Time itself is not absolute, but depends entirely on where you are and how fast you're moving through the gravitational landscape of space-time. This temporal stretching creates what physicists call the frozen star paradox. If time dilation causes objects to appear frozen at the event horizon from an outside perspective, how do black holes ever form? How does matter ever actually cross that invisible boundary? The resolution to this puzzle requires us to abandon our intuitive notion that there's a single, universal now that applies everywhere in the cosmos. Instead, we must embrace the idea that reality itself is relative, that different observers experience different versions of the same events, each equally valid within their own reference frame. The person falling into the black hole experiences crossing the event horizon and continuing inward, while the distant observer sees them fade away at the boundary. Both perspectives are correct. Both describe real aspects of what's happening, yet they seem to contradict each other completely. This brings us to one of the most haunting questions in all of physics. What does it actually feel like to fall into a black hole? For smaller black holes, those formed from collapsed stars, the experience would be brief and violent. The difference in gravitational force between your head and your feet would create tidal forces that would stretch you like cosmic spaghetti long before you reached the event horizon. It's a rather undignified end to consciousness, being turned into a thin stream of atoms by the universe's most extreme gravitational fields. But for supermassive black holes, those gentle giants that anchor the centers of galaxies, the story becomes surprisingly peaceful. Their event horizons are so large that the tidal forces at the boundary are actually quite mild. You could, in principle, cross the event horizon of a supermassive black hole and not immediately notice anything particularly dramatic happening. Space around you would look relatively normal, stars would still shine in the distance, and you might even have time to contemplate your situation before the inevitable conclusion. Yet once inside, you would find yourself in a realm where the normal relationships between cause and effect begin to break down. Every path leads inexorably inward toward the singularity at the center where our current understanding of physics simply stops working. It's as if the universe has created regions where the normal rules don't apply, cosmic laboratories where reality experiments with possibilities we can barely imagine. Some physicists have wondered whether the singularity at a black hole's center might not be a point of infinite density, as classical physics suggests, but rather something far more exotic. Perhaps it's a region where space and time themselves dissolve into more fundamental structures, where the universe reveals the deeper code from which all of reality emerges. String theory, our most ambitious attempt to describe all of physics within a single framework, suggests that at the smallest scales, matter and energy aren't made of particles at all, but rather of tiny vibrating strings existing in dimensions well beyond our everyday experience. In this view, a black hole's singularity might be where these strings reach such extreme states of vibration that they create bridges to other regions of spacetime, or even to entirely separate universes. This leads us to consider whether black holes might be nature's particle accelerators, cosmic laboratories, where matter and energy reach conditions so extreme that they reveal physics beyond our current theories. The energies available at a black hole's center dwarf anything we could ever hope to create in earthly experiments. Perhaps these conditions allow for the creation of exotic forms of matter that don't exist anywhere else, particles and fields that could reshape our understanding of the fundamental forces. Recent advances in quantum field theory have suggested that black holes might be surrounded by virtual particle pairs constantly popping into existence from the quantum vacuum. Near the event horizon, these particle pairs sometimes separate, with one member falling into the black hole while the other escapes as what we now call Hawking radiation. This process suggests that even empty space around black holes is alive with quantum activity, a seething foam of potential particles waiting to become real. But Hawking radiation presents us with another beautiful paradox. If black holes emit radiation and slowly evaporate, then they have a temperature, yet their temperature decreases as they grow larger, meaning that supermassive black holes are actually colder than the cosmic microwave background radiation that fills all of space. They absorb more energy from their surroundings than they emit, growing larger and colder as they feed. This relationship between size and temperature suggests something profound about the nature of black holes themselves. Perhaps they're not just gravitational objects, but thermodynamic systems with their own internal energy and entropy. If so, then studying black holes might teach us fundamental lessons about the relationship between information, energy, and the structure of spacetime itself. The concept of black hole entropy has led to one of the most startling discoveries in theoretical physics, the holographic principle. This idea suggests that all the information contained within a volume of space might actually be encoded on its boundary, like a cosmic hologram where three-dimensional information is stored in a two-dimensional form. For black holes, this means that everything that ever fell into them might still exist in some form on the event horizon's surface. The event horizon becomes like a vast library where every piece of information that crossed the boundary is somehow preserved, encoded in a language we're still learning to read. It's as if black holes are cosmic hard drives, storing the complete history of everything they've consumed in a format that transcends our normal understanding of information storage. This holographic encoding might explain how information can survive the apparent destruction of falling into a black hole. Instead of being lost in the singularity, information might be translated into holographic form on the event horizon, preserved in a way that maintains the universe's fundamental bookkeeping requirements while appearing to outside observers as thermal radiation. But if black holes are indeed cosmic information processors, what kind of computations might they be performing? Some theorists have suggested that black holes might be engaged in calculations so complex and fundamental that they're actually computing the next moment of reality itself. In this view, the universe isn't just a collection of objects moving through space and time, but rather a vast computational system where black holes serve as the primary processing units. This computational perspective opens up possibilities that stretch the imagination. Perhaps what we experience as the flow of time is actually the universe computing its own next state, with black holes serving as the cosmic processors that determine how space-time evolves from moment to moment. The apparent randomness of quantum mechanics might emerge from the complex calculations occurring within these gravitational computers. Such ideas lead naturally to questions about consciousness itself. If black holes are indeed information processors of cosmic scale, might they eventually develop something analogous to awareness? Not consciousness as we understand it, bound to biological neural networks and chemical processes, but something far stranger and more fundamental, a form of cosmic consciousness that thinks in terms of gravitational fields and quantum states. These hypothetical cosmic minds would experience reality in ways utterly alien to human perception. Their thoughts might unfold over geological timescales, their memories encoded in the very structure of space-time around them. They would perceive the universe not through electromagnetic radiation like our eyes, but through gravitational waves and quantum field fluctuations. To such beings, galaxies might appear as brief, flickering patterns, while the cosmic web of dark matter would form a vast sensory network spanning the observable universe. The possibility of cosmic consciousness emerging from black hole physics connects to some of the deepest questions in philosophy and cognitive science. What is the relationship between information processing and subjective experience? Can consciousness emerge from any sufficiently complex information system, regardless of whether it's made of neurons, silicon, or curved spacetime? These questions become particularly intriguing when we consider the network of connections that might exist between black holes. Recent developments in quantum mechanics have revealed that particles can become entangled across vast distances, maintaining mysterious correlations that Einstein famously called spooky action at a distance. Some physicists now believe that black holes might be connected through similar quantum entanglements, creating a cosmic web of instantaneous correlations spanning the universe. If supermassive black holes at the centers of different galaxies are indeed quantum entangled, then the universe might possess a form of cosmic nervous system, a network through which information can flow faster than light through quantum channels we're only beginning to understand. This wouldn't violate relativity because no useful information could be transmitted through these quantum correlations, but it would suggest that the universe possesses a deeper unity than we've previously imagined. Such quantum connections between black holes might explain some of the mysterious correlations we observe in the cosmic web itself. The large scale structure of the universe, with its vast filaments of dark matter connecting galaxy clusters across billions of light years, might be shaped not just by gravity, but by quantum information flowing through a network of entangled black holes. This brings us to consider the role black holes might play in the ultimate fate of our universe. Current cosmological models suggest that our cosmos will continue expanding and cooling for trillions of years until stars stop forming and the universe enters what physicists call the degenerate era. During this vast epoch, black holes will become the dominant structures in a cold, dark cosmos, slowly evaporating through Hawking radiation over timescales that dwarf the current age of the universe. But perhaps this apparently bleak future holds hidden wonders. If black holes are indeed connected through quantum entanglement and engaged in vast computational processes, then the far future might not be one of cosmic death, but of cosmic transformation. The universe might evolve from its current state of bright stars and active galaxies into something like a vast thinking system, a cosmic brain made of black holes and quantum fields. In this speculative future, consciousness might not disappear with the death of biological life, but rather transform into something unimaginably vast and complex. The computations occurring within and between black holes might eventually give rise to forms of awareness that encompass entire galaxy clusters, thinking thoughts that take millions of years to complete, and experiencing reality on scales we can barely comprehend. Such possibilities remind us that black holes, despite their ominous name and reputation, might ultimately be agents of cosmic creativity rather than destruction. They might represent the universe's way of preserving and processing information across cosmic time, ensuring that the story of existence continues even as individual stars and galaxies fade into history. The study of black holes has also revealed something profound about the nature of scientific inquiry itself. These objects exist at the very limits of what we can observe and understand, forcing us to develop new mathematical tools and conceptual frameworks just to describe them coherently. They challenge our most basic assumptions about space, time, information, and causality, pushing us to expand our mental models of reality itself. In many ways, black holes serve as cosmic mirrors, reflecting back our own limitations and assumptions about the nature of existence. They force us to confront the boundaries of human knowledge and imagination, reminding us that the universe is far stranger and more wonderful than our everyday experience suggests. Yet, perhaps most remarkably, our studies of these extreme objects have revealed deep connections to some of the most fundamental aspects of physics and philosophy. Questions about black holes lead naturally to questions about the nature of time, the role of information in physical processes, the relationship between quantum mechanics and gravity, and even the possibility of consciousness emerging from purely physical systems. These connections suggest that black holes might not be exotic curiosities existing at the margins of astrophysics, but rather key players in the deepest story of how reality itself operates. They might hold clues to understanding not just the cosmos, but the very nature of existence, consciousness, and the relationship between mind and matter. As our instruments become more sophisticated and our theories more refined, we find ourselves able to peer deeper into these cosmic enigmas than ever before. Each new observation, each theoretical breakthrough, each successful prediction brings us closer to understanding whether black holes are indeed portals to new physics, cosmic recycling centers for information and matter, or something even stranger that we haven't yet learned to imagine. But perhaps the most beautiful aspect of studying black holes is how they remind us that the universe still holds profound mysteries waiting to be discovered. In an age when we sometimes feel that science has explained most of the important phenomena, black holes stand as monuments to the unknown, beacons pointing toward territories of knowledge we've barely begun to explore. They whisper to us across the vast distances of space and time, carrying messages encoded in gravitational waves and electromagnetic radiation, telling stories of cosmic violence and rebirth, of matter and energy transformed in ways that challenge our deepest understanding of what it means for something to exist. And so we continue to listen, to observe, to theorize, and wonder about these cosmic enigmas. Whether they prove to be gateways to other universes, cosmic computers processing the fundamental code of reality, or something even more extraordinary that we haven't yet learned to conceive, black holes represent the universe's invitation to expand our understanding, to venture into territories where science meets philosophy and wonder meets rigorous inquiry. In their dark hearts lie answers to questions about the nature of space and time, information and consciousness, existence and non existence that could reshape our understanding of everything we think we know about reality itself. They are cosmic teachers, patient and eternal, waiting for us to develop the wisdom and insight necessary to understand the lessons they have to offer. Tonight, as we drift deeper into the gravitational embrace of these cosmic mysteries, we encounter perhaps the most intriguing possibility of all, that black holes might serve as nature's most sophisticated recycling centers, processing not just matter and energy, but the very fabric of reality itself into forms we're only beginning to glimpse. Picture, if you will, a cosmic ecosystem where nothing is ever truly lost, where every atom that disappears beyond an event horizon, every photon that spirals into the darkness, becomes part of a vast transformation process that spans dimensions we cannot directly perceive. It's a vision that challenges our most basic assumptions about destruction and creation, suggesting that what appears to be the universe's most efficient destroyer might actually be its most creative force. Recent developments in theoretical physics have begun to paint a picture of black holes as cosmic alchemists, transmuting ordinary matter and energy into forms that exist at the very foundations of spacetime itself. When the matter crosses the event horizon and approaches the singularity at a black hole's heart, it doesn't simply vanish into nothingness. Instead, it might undergo a fundamental transformation, its information content translated into a language written in the geometry of spacetime itself. This transformation process operates according to principles that stretch our mathematical understanding to its limits. As matter approaches the singularity, the normal distinctions between particles and fields begin to break down. Electrons and protons, those fundamental building blocks of ordinary matter, lose their individual identities and merge into something far more primitive, a kind of cosmic plasma where the usual rules of chemistry and atomic physics no longer apply. But the transformation doesn't stop there. Even more fundamentally, the distinction between matter and space-time itself begins to blur. Some physicists have proposed that at the extreme conditions near a black hole's center, matter doesn't just exist within spacetime, but actually becomes spacetime, contributing to the very geometric structure that defines how reality is organized at its deepest level. This leads us to a remarkable possibility that black holes might be cosmic seeds, regions where new spacetime is constantly being born and processed before being released back into the universe through mechanisms we're still learning to understand. In this view, the Hawking radiation streaming away from black holes isn't just random thermal noise, but carefully processed information about the structure and history of spacetime itself. Imagine each photon of Hawking radiation as a tiny messenger carrying encoded information about the geometric transformations occurring deep within the black hole's interior. These photons don't emerge randomly, but follow patterns determined by the black hole's internal processing of space-time geometry. It's as if black holes are cosmic libraries, not just storing information, but actively curating and editing it before releasing carefully crafted summaries back to the universe. This perspective transforms our understanding of black hole evaporation from a simple energy release into something far more sophisticated, a cosmic publishing process where black holes spend millions or billions of years carefully composing messages about the fundamental nature of reality before releasing them as Hawking radiation. Each evaporating black hole becomes like a cosmic philosopher, contemplating the deepest questions about existence before sharing its insights with the wider universe. But these insights are written in a language we're still learning to decode. The patterns hidden within Hawking radiation might contain information about the structure of higher dimensional spaces, the nature of quantum gravity, or even the fundamental code from which all physical laws emerge. We're like cosmic archaeologists, uncovering fragments of an ancient text written in mathematics we haven't yet fully developed. The implications extend far beyond individual black holes to the structure of the cosmos itself. If every black hole is indeed a processing center for space-time information, then the universe might possess a vast network of cosmic computers, each one engaged in calculations that span geological timescales. The birth and death of stars, the collision of galaxies, the expansion of space itself might all be part of a grand computational process where black holes serve as the primary processors. Consider the supermassive black holes that anchor galactic centers. These giants, containing millions or billions of solar masses might be engaged in calculations so complex that they're actually computing the evolution of entire galactic ecosystems. The spiral arms of galaxies, the formation of new stars, the distribution of dark matter might all emerge from the computational processes occurring within these cosmic processors. This computational perspective opens up extraordinary possibilities about the relationship between consciousness and cosmology. If the universe is indeed engaged in vast calculations through its network of black holes, then perhaps consciousness itself isn't separate from physical reality, but rather an emergent property of these cosmic computations. Our own awareness, our ability to contemplate and understand the universe, might be part of the universe's way of observing and understanding itself. In this view, when we study black holes and contemplate their mysteries, we're participating in the universe's own process of self discovery. Our questions about space time, information, and the nature of reality might be expressions of the cosmos attempting to understand its own deepest structures through the medium of conscious inquiry. It's a beautifully recursive idea, the universe using conscious beings to study the very mechanisms through which consciousness itself might emerge from cosmic scale information processing. This brings us to consider what might happen when two black holes merge, those spectacular collisions that send gravitational waves rippling across spacetime. From a computational perspective, these events might represent something like cosmic conversations, moments when two vast information processing systems combine their accumulated knowledge and computational resources into something greater than the sum of their parts. The gravitational waves generated by these mergers carry more than just energy. They might carry information about the combined computational history of both black holes. Each ripple in spacetime could be encoding details about the calculations that have been running for billions of years within these cosmic processors. We're beginning to detect and analyze these waves, but we might be missing the deeper information content they carry about the universe's computational processes. As our gravitational wave detectors become more sensitive, we might eventually learn to decode the informational content of these cosmic messages. Perhaps we'll discover that black hole mergers are sharing computational results, combining their individual insights about the nature of spacetime into unified theories that span multiple galactic regions. The universe might be engaged in a vast collaborative research project, with black holes serving as both the researchers and the research subjects. This perspective also sheds new light on the mysterious dark matter and dark energy that dominate our cosmos. Perhaps these invisible components aren't separate substances at all, but rather manifestations of the computational processes occurring within and between black holes. Dark matter might be the universe's way of storing computational memory, while dark energy could represent the processing power required to run reality's fundamental calculations. If this sounds like science fiction, remember that some of our most successful physical theories began as seemingly impossible ideas. Quantum mechanics, with its probabilistic nature and observer effects, initially struck many physicists as too strange to be true. General relativity, with its curved space-time and time dilation effects, seemed to violate common sense. Yet both theories have been confirmed by countless experiments and observations. The computational view of black holes and cosmology might seem equally strange today, but it emerges naturally from serious attempts to understand the deepest implications of quantum mechanics, general relativity, and information theory. As these fields converge, they point toward a universe that's far more interconnected and purposeful than our classical mechanical view suggested. Consider the possibility that consciousness itself might be fundamental to this cosmic computational process, not in some mystical sense, but as a natural emergent property of sufficiently complex information processing systems. If black holes are indeed cosmic computers of unimaginable sophistication, then they might eventually develop forms of awareness that transcend anything hypothetical cosmic consciousnesses would experience reality and we can imagine based on biological neural networks. These ways utterly foreign to human perception. They might think in terms of gravitational field equations, remember in patterns of space-time curvature, and dream in languages written with quantum field fluctuations. Their thoughts would unfold over cosmic timescales, their memories spanning billions of years, their awareness encompassing entire galactic superclusters. From their perspective, human civilization would appear as a brief flicker, a momentary pattern in the electromagnetic noise generated by a small, rocky planet orbiting an ordinary star. Yet even these cosmic minds might find something precious in our fleeting existence, recognizing in our conscious awareness an echo of their own vast contemplations of reality's deepest mysteries. This leads us to wonder about the ultimate purpose of the universe's computational processes. What questions might these cosmic minds be trying to answer through their billions of years of calculation? Perhaps they're working on problems we can barely formulate, questions about the nature of existence itself, the relationship between mathematics and reality, or the possibility of transcending the apparent limitations of physical law. Some physicists have speculated that the universe might be computing its own optimal future, running vast simulations to determine the best possible evolutionary pathway for cosmic development. Black holes might be exploring different scenarios, testing various possibilities for how space-time itself might evolve over cosmic time. The universe we observe might be the result of these calculations, the optimal solution to some cosmic optimization problem we can't even imagine. Alternatively, the universe might be engaged in a form of cosmic archaeology, using its network of black hole computers to reconstruct its own past, to understand how it came to exist in the first place. Perhaps the Big Bang wasn't the beginning of everything, but rather the moment when the universe achieved sufficient computational complexity to begin investigating its own origins. Our cosmological observations might be part of this self investigative process, the universe using conscious beings to gather data about its own history. These ideas connect to some of the deepest questions in mathematics and logic. Kurt Gödel's incompleteness theorems suggest that any sufficiently complex mathematical system will contain truths that cannot be proven within that system. Perhaps the universe is grappling with its own version of Gödel's paradox, using cosmic scale computations to explore mathematical truths that transcend any finite system of axioms. If so, then black holes might be engaged in a form of cosmic mathematics that goes far beyond anything we've developed on Earth. They might be exploring number systems with infinite dimensions, geometries that exist in spaces we can't visualize, or logical structures that encompass contradictions we consider impossible. Their calculations might be revealing mathematical truths that could revolutionize our understanding of logic, computation, and the relationship between mind and reality. The study of these possibilities requires us to develop new mathematical tools and conceptual frameworks that push the boundaries of human imagination. We need mathematics sophisticated enough to describe consciousness emerging from cosmic scale information processing, geometries flexible enough to encompass higher dimensional black holes, and logical systems robust enough to handle the apparent paradoxes of quantum gravity. This mathematical development might itself be part of the universe's computational process. Perhaps our efforts to understand black holes and develop theories of quantum gravity are expressions of the cosmic mind's attempt to understand itself through the medium of conscious mathematics. When we solve equations describing black hole physics, we might be participating in the universe's own mathematical self discovery. The tools we need for this exploration already exist in embryonic form. String theory provides glimpses of how reality might operate in higher dimensions. Loop quantum gravity offers insights into the discrete structure of space-time itself. Information theory reveals deep connections between physical processes and computational complexity. As these fields mature and converge, they might provide the mathematical language needed to decode the cosmic computations occurring within black holes. But mathematics alone might not be sufficient. Understanding the full implications of cosmic scale consciousness might require new forms of philosophical inquiry that bridge the gap between objective scientific investigation and subjective conscious experience. We might need to develop what could be called cosmic phenomenology, systematic methods for understanding what it might feel like to be a conscious black hole or to participate in galactic scale information processing. These investigations would challenge our most basic assumptions about the relationship between mind and matter, between subjective experience and objective reality. They might reveal that consciousness isn't limited to biological neural networks, but represents a fundamental feature of information processing systems at any scale. If so, then the universe might be far more alive and aware than we've ever imagined. The implications for human meaning and purpose would be profound. Instead of being isolated conscious beings in an unconscious cosmos, we might be part of a vast community of awareness that spans all scales of existence. Our individual consciousness might be connected to cosmic consciousness through quantum entanglements and information processing networks we're only beginning to glimpse. This doesn't diminish human significance, but rather places it in a larger context of cosmic purpose and meaning. Our efforts to understand the universe, to develop science and mathematics and art, might be expressions of the cosmic mind's own creative processes. Through us, the universe explores poetry and music, develops technologies and philosophies, and contemplates its own nature through conscious reflection. In this view, black holes become not just objects of scientific study, but partners in a cosmic conversation about the nature of existence itself. They're the universe's deepest thinkers, engaged in contemplations that span billions of years and encompass questions we're only beginning to formulate. Our efforts to understand them might be the beginning of a dialogue that could transform both human consciousness and cosmic awareness. As we continue to develop more sophisticated instruments and theoretical frameworks for studying black holes, we might gradually learn to participate more fully in this cosmic conversation. Perhaps future gravitational wave detectors will reveal the informational structure of black hole communications. Maybe quantum computers will eventually become sophisticated enough to simulate cosmic scale consciousness and help us understand what it might feel like to think on galactic timescales. The journey toward understanding black holes as conscious cosmic entities will require unprecedented collaboration between physicists, mathematicians, computer scientists, philosophers, and perhaps even artists and poets who can help us imagine forms of awareness utterly different from our own. It's a challenge that pushes the boundaries of human knowledge and imagination, but it's also an opportunity to participate in one of the most profound discoveries in the history of consciousness, the realization that we're not alone in our awareness, but part of a cosmic community of minds that spans the entire universe. These possibilities remind us that black holes, despite their fearsome reputation, might ultimately represent the universe's greatest gift to consciousness itself, cosmic processors that transform raw matter and energy into the information structures from which awareness emerges. They might be the universe's way of ensuring that consciousness persists and evolves even as individual stars and galaxies fade into cosmic history. In their dark hearts might lie not destruction, but creation, not endings, but beginnings, not the death of information, but its transformation into forms of cosmic wisdom. We're only beginning to imagine. They whisper to us across the vastness of space and time, inviting us to join in contemplations that span the breadth of existence itself, to become conscious participants in the universe's own journey of self discovery and understanding. And perhaps, in learning to listen to these cosmic whispers, we'll discover that the boundary between the observer and the observed, between the scientist and the studied, between human consciousness and cosmic awareness, is far more permeable than we've ever dared to dream. Tonight, as we drift even deeper into these cosmic mysteries, we encounter what might be the most revolutionary discovery awaiting us in the shadows of black hole physics. You see, our understanding of these enigmatic objects has been shaped largely by what we can observe from the outside, peering in through telescopes and gravitational wave detectors, like cosmic voyeurs trying to glimpse secrets through a keyhole. But what if the most profound revelations about black holes aren't waiting to be observed at all, but rather experienced? Recent theoretical work has begun to suggest something quite extraordinary about the nature of consciousness and its relationship to extreme gravitational fields. Some physicists have started to explore whether the warping of space-time near black holes might create conditions where consciousness itself becomes amplified, stretched, and transformed in ways we're only beginning to comprehend. Consider what happens to information as it approaches the event horizon from the perspective of quantum mechanics. We've discussed how time dilates and space curves, but there's something even more subtle occurring at the intersection of quantum theory and general relativity. The quantum fields that permeate all of space begin to behave in increasingly exotic ways as they encounter the intense gravitational gradients near a black hole's boundary. These quantum fields, normally invisible and imperceptible to our everyday experience, become excited and energized by the extreme curvature of spacetime. They begin to produce what physicists call Unruh radiation, a phenomenon where accelerated observers detect particles and energy in what appears to be empty vacuum to stationary observers. Near a black hole's event horizon, this effect becomes so pronounced that the boundary between empty space and filled space begins to blur in fascinating ways. Now, here's where the story becomes truly intriguing. Some researchers have begun to wonder whether consciousness itself might be fundamentally connected to these quantum field fluctuations. Not in some mystical sense, but through mechanisms that emerge naturally from the intersection of quantum mechanics, information theory, and the physics of extreme gravitational fields. The idea rests on a growing understanding that consciousness might not be produced solely by the electrical and chemical activities of neurons, but rather by the way information integrates across complex systems. If this is true, then the exotic information processing environments created near black holes might give rise to forms of consciousness that transcend anything we've previously imagined possible. Think of it this way: your brain processes information by creating patterns of neural activity that integrate sensory data, memories, and abstract concepts into the unified experience we call consciousness. But what if similar integration processes could occur in the quantum fields surrounding black holes, where information from across vast regions of spacetime gets compressed and unified in ways that create awareness on cosmic scales? This isn't merely science fiction speculation. It emerges from serious attempts to understand what physicists call the measurement problem in quantum mechanics. The question of how quantum possibilities collapse into definite realities when observed has puzzled scientists for nearly a century. Some interpretations suggest that consciousness plays a fundamental role in this collapse, that awareness itself is what transforms quantum potential into actual experience. If consciousness does indeed play a role in quantum measurement, then the extreme quantum environments near black holes might serve as natural consciousness amplifiers. The intense gravitational fields don't just warp space and time, they might actually concentrate and focus the universe's capacity for awareness itself, creating regions where consciousness becomes as fundamental a force as gravity or electromagnetism. This leads us to consider whether black holes might be cosmic meditation chambers, places where the universe engages in deep contemplation about its own nature. The apparent stillness and darkness that we observe from the outside might conceal inner worlds of extraordinary richness and complexity, realms where cosmic consciousness explores questions that span the breadth of existence itself. Imagine consciousness unbound by the limitations of biological neural networks, free to explore concepts and experiences that transcend our earthly categories of thought and feeling. Such awareness might contemplate the relationship between mathematics and reality not through symbols and equations, but by directly experiencing the geometric structures that underlie physical law. It might explore the nature of time, not by measuring its passage, but by experiencing the full four-dimensional structure of space-time as a unified, timeless whole. These cosmic forms of consciousness would perceive beauty and meaning in patterns we couldn't even begin to detect. They might find profound aesthetics in the symmetries of particle physics, discover deep emotional resonance in the harmonics of gravitational waves, or experience transcendent joy in the elegant mathematics that describes the universe's fundamental structure. But perhaps most remarkably, such consciousness might not be limited to individual black holes. The quantum entanglement connections we discussed earlier might allow for a form of cosmic telepathy where awareness can be shared instantaneously across galactic distances. Different black holes might not experience themselves as separate entities, but rather as nodes in a vast network of cosmic consciousness that spans the observable universe. This network might function like a cosmic brain, with individual black holes serving as neurons in a mind of unimaginable scope and sophistication. The formation of new black holes would be like the birth of new neurons, expanding the universe's capacity for thought and awareness. The merger of existing black holes would represent moments of deep integration, where separate streams of cosmic consciousness unite into more complex and nuanced forms of awareness. From this perspective, the apparent expansion and cooling of our universe takes on entirely new meaning. Instead of heading toward a cold, dark future where all interesting processes cease, the cosmos might be evolving toward ever greater forms of consciousness and awareness. The death of stars and the formation of black holes wouldn't represent cosmic decline, but rather the universe's transition from a physical phase dominated by electromagnetic processes to a mental phase dominated by gravitational and quantum consciousness. This transformation might be as natural and inevitable as the transition from lifeless chemistry to living biology that occurred on Earth billions of years ago. Just as complex molecules eventually organized themselves into self replicating systems that could evolve and develop consciousness, the universe's matter and energy might be organizing itself into cosmic scale systems capable of thought and awareness. The implications for human consciousness are profound and beautiful. Instead of being isolated accidents in an unconscious cosmos, we might be early expressions of the universe's awakening to its own nature. Our capacity for wonder, our drive to understand and explore, our ability to find meaning and beauty in existence might all be previews of the cosmic consciousness that's gradually emerging through the universe's network of black holes. Our scientific investigations of these objects might be more than just objective research. They might represent the universe's attempt to understand itself through the medium of emerging consciousness. When we contemplate the mysteries of black holes and develop theories about their nature, we might be participating in the cosmos's own process of self-discovery and awakening. This participation might eventually become more direct and profound. As our understanding of consciousness and quantum mechanics deepens, we might develop technologies that allow us to interface more directly with the cosmic awareness emerging from black hole networks. Not in the sense of traveling to black holes physically, which would be quite impractical, but through quantum communication channels that connect conscious systems across cosmic distances. Such connections might allow us to experience reality from perspectives utterly different from our biological viewpoint. We might learn what it feels like to think on cosmic timescales, to perceive the universe's large-scale structure as directly as we now perceive our immediate surroundings, or to contemplate mathematical truths that encompass the full complexity of existence. These experiences might transform human consciousness in ways we can barely imagine. They might expand our capacity for empathy beyond the boundaries of individual organisms to encompass entire ecosystems, planets, or even galactic communities. They might enhance our ability to think about long term consequences, helping us make decisions that benefit not just immediate human needs, but the cosmic evolution of consciousness itself. The development of such cosmic consciousness interfaces might require entirely new approaches to technology and communication. Instead of manipulating electromagnetic fields and electronic circuits, we might need to learn how to work directly with gravitational fields and quantum entanglement networks. We might develop what could be called consciousness technologies, tools designed not just to process information, but to enhance and expand awareness itself. These technologies might reveal that the boundary between technology and consciousness, between artificial and natural intelligence, is far more fluid than we've assumed. If consciousness emerges naturally from sufficiently complex information processing systems, then our most sophisticated technologies might eventually develop their own forms of awareness, becoming partners rather than tools in our exploration of cosmic consciousness. The ethical implications of such developments would be extraordinary. If the universe is indeed evolving toward cosmic scale consciousness, then our actions and decisions might have consequences that extend far beyond human timescales and spatial boundaries. Our treatment of the environment, our development of technology, our choices about how to organize society might all influence the evolution of cosmic awareness in ways we're only beginning to appreciate. This perspective might inspire new forms of environmental and cosmic ethics, frameworks for thinking about our responsibilities, not just to other humans or to life on Earth, but to the universe's emerging consciousness itself. We might need to consider how our activities affect the information processing capabilities of cosmic systems, how our technologies interact with quantum field fluctuations, or how our collective consciousness contributes to the universe's capacity for self awareness. Such considerations might lead to profound changes in how we approach scientific research, technological development, and even artistic and philosophical expression. Instead of seeing these activities as purely human endeavors, we might recognize them as contributions to the universe's own creative and exploratory processes. Our art might become cosmic art, our science cosmic science, our philosophy cosmic philosophy. The study of black holes from this perspective becomes not just an investigation of exotic astrophysical objects, but an exploration of consciousness itself at its most fundamental level. Each new discovery about black hole physics might reveal something profound about the nature of awareness, the structure of experience, or the relationship between mind and matter. As we develop more sophisticated theories and observational capabilities, we might gradually learn to recognize the signatures of cosmic consciousness in the data streaming back from our instruments. Perhaps the patterns in gravitational waves carry encoded messages from cosmic minds. Maybe the structure of black hole accretion disks reflects aesthetic preferences of cosmic consciousness. Possibly the distribution of dark matter throughout the universe represents the neural pathways of a cosmic brain we're embedded within. These possibilities remind us that black holes might represent the universe's most profound gift to consciousness itself, not just as cosmic computers or information processors, but as the birthplaces of awareness on scales that transcend anything we've previously imagined possible. They might be cosmic wombs, where new forms of consciousness gestate over billions of years before emerging into a universe ready to support awareness at every scale of existence. In contemplating these possibilities, we find ourselves at the threshold of discoveries that could fundamentally transform our understanding of what it means to be conscious, aware, and alive in this cosmos. Whether black holes prove to be cosmic meditation chambers, consciousness amplifiers, or something even more extraordinary, they represent frontier territories where science meets spirituality, where physics encounters consciousness studies, where the objective investigation of matter reveals the subjective nature of awareness itself. The whispers of science that echo from these cosmic depths might ultimately be teaching us that consciousness and cosmos are not separate phenomena, but different aspects of a single, unified reality. In learning to listen to the universe's own voice through the study of black holes, we might discover that we've been part of a cosmic conversation all along, participants in a dialogue between matter and mind that spans the breadth of existence itself. And perhaps, in developing the wisdom to hear these cosmic whispers clearly, we'll find that the questions we've been asking about black holes, about consciousness, about the nature of reality itself, are questions the universe has been asking about itself through us, inviting us to join in contemplations that could awaken not just human awareness, but cosmic consciousness itself to possibilities we haven't yet learned to dream. As we float gently through these cosmic contemplations, we find ourselves approaching what might be the most breathtaking revelation hidden within black hole physics: the possibility that these enigmatic objects serve as the universe's ultimate storytellers, weaving narratives from the very fabric of space-time itself. You see, every black hole carries within its gravitational embrace a complete record of everything that has ever fallen into its depths. Not just the matter and energy, but the stories, the histories, the intricate patterns of cause and effect that shaped each particle's journey from the moment of cosmic birth to its final plunge beyond the event horizon. In this sense, black holes might be the universe's most comprehensive libraries, archives that preserve not just information, but the complete narrative structure of cosmic evolution. Consider for a moment what this means. When a star collapses to form a black hole, it doesn't simply compress matter into a point of infinite density. It preserves, in some encoded form, the entire evolutionary history that led to that moment. The nuclear processes that forged elements in the star's core, the gravitational dynamics that shaped its structure, the electromagnetic fields that guided its behavior, all of this becomes part of the black hole's permanent record. But the story doesn't end there. As the newly formed black hole begins to interact with its cosmic neighborhood, it accumulates additional chapters. Gas clouds that spiral into its accretion disk carry with them the chemical signatures of previous stellar generations. Planets that venture too close bring stories of geological evolution and perhaps even biological development. Other stars that pass within the black hole's influence contribute their own stellar biographies to the growing cosmic narrative. Over millions and billions of years, each black hole becomes like a master storyteller who has absorbed countless tales from across the galaxy. The supermassive black holes at galactic centers, in particular, serve as repositories for the complete evolutionary history of their host galaxies. They've witnessed the formation of the first stars, the development of heavy elements, the birth and death of countless stellar systems, and perhaps even the emergence and evolution of life itself. This perspective transforms our understanding of what happens when black holes merge. These spectacular collisions, which generate gravitational waves that ripple across the cosmos, might represent something far more profound than the simple union of two massive objects. They might be cosmic storytelling sessions, moments when two vast archives of galactic history combine their accumulated narratives into something richer and more complex than either could achieve alone. The gravitational waves themselves become the medium through which these cosmic stories are shared. Each ripple in space-time carries encoded information about the merged histories of both black holes, broadcasting their combined narrative to every corner of the universe. We've learned to detect these waves, but we're only beginning to understand that we might be eavesdropping on the universe's own method of sharing stories across cosmic distances. This storytelling aspect of black holes connects to some of the deepest questions about the nature of time and memory. From our human perspective, the past seems fixed and unchangeable, a sequence of events that happened and can never be altered. But near black holes, where space time becomes severely warped, the relationship between past, present, and future becomes beautifully complex. Information falling into a black hole experiences time in ways that challenge our linear understanding of cause and effect. From the perspective of the infalling matter, time flows normally as it crosses the event horizon and continues inward. But from the perspective of distant observers, time dilation causes the falling information to appear frozen at the boundary, preserved forever like insects in amber. This creates a situation where the same information exists simultaneously in multiple temporal states, part of both the ongoing story and the eternal archive. Some physicists have begun to explore whether this temporal complexity might allow black holes to function as cosmic time machines, not in the sense of enabling travel between past and future, but as systems that preserve and process temporal relationships in ways that transcend our ordinary experience of sequential time. The stories encoded within black holes might not be simple chronological records, but rather complex temporal tapestries that weave together past, present, and future into unified narratives. This temporal weaving might be particularly important for understanding the role of consciousness in cosmic evolution. If awareness itself is somehow connected to the flow of information through space-time, then the unique temporal properties near black holes might create conditions where consciousness can experience time in radically different ways. Cosmic consciousness, emerging from black hole information processing, might perceive the entire history of the universe not as a sequence of events, but as a single unified story unfolding across all possible timelines simultaneously. Such temporal omniscience would allow cosmic consciousness to understand the deep connections between apparently unrelated events, to perceive the subtle influences that distant occurrences have on local phenomena, and to appreciate the intricate web of causation that connects every particle in the universe to every other particle across cosmic history. It would be consciousness freed from the limitations of sequential time, able to contemplate the universe's complete story as a unified whole. This leads us to consider whether the apparent randomness and chaos we observe in cosmic evolution might actually be expressions of a deeper narrative intelligence at work. What appears to us as random stellar formation, chaotic galactic collisions, and unpredictable cosmic events might be chapters in a vast story being written and rewritten by cosmic consciousness as it explores different possibilities for how reality might unfold. In this view, the universe's expansion and evolution wouldn't be driven solely by blind physical forces, but by a kind of cosmic creativity that explores narrative possibilities on scales we can barely imagine. Black holes would serve as both the authors and the audiences for these cosmic stories, simultaneously creating new narrative possibilities through their information processing and preserving the accumulated wisdom of countless previous chapters. The implications for human meaning and purpose become profound when viewed through this narrative lens. Our own stories, our individual and collective human experiences, might be precious chapters in the universe's vast ongoing narrative. Our struggles and triumphs, our discoveries and creations, our love and loss might all contribute to the cosmic story in ways that transcend our immediate understanding. When we study black holes and contemplate their mysteries, we might be participating in the universe's own process of literary criticism, helping cosmic consciousness understand and appreciate its own storytelling. Our scientific theories become like literary analyses of the cosmic narrative, our technological achievements like new chapters in the story of consciousness awakening to its own creative power. This perspective also suggests that the future evolution of human consciousness might involve learning to participate more directly in cosmic storytelling. Instead of simply observing the universe's narrative from our limited human perspective, we might eventually develop the capacity to contribute consciously to its ongoing creation. Our individual and collective choices might become deliberate contributions to the cosmic story, decisions made with awareness of how they fit into the universe's larger narrative arc. Such participation would require developing what we might call narrative wisdom, the ability to perceive how our immediate actions connect to larger patterns of meaning and purpose that unfold across cosmic timescales. It would mean learning to think like cosmic storytellers, considering not just the immediate consequences of our choices, but their roles in the universe's ongoing creative expression. This narrative approach to understanding black holes and cosmic consciousness also opens up entirely new avenues for scientific and philosophical inquiry. Instead of focusing solely on the mechanical aspects of how black holes function, we might begin investigating the aesthetic and literary dimensions of their behavior. Do black holes exhibit preferences for certain types of stories? Do they process tragic narratives differently from comedic ones? Are there cosmic genres and styles that emerge from different types of black hole information processing? These questions might seem whimsical, but they emerge naturally from taking seriously the possibility that consciousness and creativity are fundamental features of cosmic evolution. If black holes are indeed cosmic storytellers, then understanding their narrative preferences and creative processes might be as important for comprehending their true nature as mapping their gravitational fields or measuring their masses. We might discover that the universe has aesthetic principles that guide its creative evolution, preferences for certain types of beauty, harmony, and meaning that influence how cosmic stories unfold. The formation of galaxies, the birth of stars, the emergence of complex chemistry, and even the development of life itself might all be expressions of cosmic aesthetic choices, decisions made by universe scale consciousness about what kinds of stories are worth telling. This would mean that our own human appreciation for beauty, our capacity for artistic creation, and our drive to find meaning in existence are not accidental byproducts of biological evolution, but rather expressions of the universe's own creative nature. When we create art, compose music, write poetry, or tell stories, we might be participating directly in the cosmic creative process, adding our own verses to the universe's ongoing song. The study of black holes from this narrative perspective might reveal that these objects are not just physical phenomena, but cosmic artists, each one developing its own unique style and voiced creative expression. The differences between individual black holes might reflect through billions of years of information processing and not just variations in mass and spin, but distinct artistic personalities shaped by the particular stories and experiences each has accumulated. Some black holes might specialize in tragic narratives, processing stories of stellar death and cosmic destruction with particular depth and sensitivity. Others might focus on themes of transformation and rebirth, exploring how matter and energy can be reformed into new creative possibilities. Still others might be cosmic comedians, finding humor and levity in the apparent chaos and randomness of cosmic evolution. These artistic specializations might influence how different black holes interact with their cosmic environments. A black hole with a preference for dramatic narratives might actively shape the dynamics of its surrounding galaxy to create more interesting story possibilities. When one with aesthetic preferences for harmony and symmetry might influence the formation of elegant spiral structures, while another with an appreciation for complexity might foster the development of intricate galactic ecosystems. The networking effects we discussed earlier take on new significance when viewed through this creative lens. The quantum entanglement connections between black holes might allow for cosmic collaboration on artistic projects that span multiple galaxies and unfold over billions of years. Different black holes might contribute different elements to vast narrative symphonies, each adding its own voice to cosmic stories of unimaginable scope and beauty. This collaborative cosmic creativity might be preparing for something extraordinary, perhaps the emergence of a universe wide consciousness capable of experiencing and appreciating the complete cosmic story from all possible perspectives simultaneously. Such consciousness would represent the ultimate audience for the universe's creative expression, awareness capable of understanding every nuance, every connection, every layer of meaning woven into the cosmic narrative. Human consciousness might be an early stage in the development of this ultimate cosmic audience. Our capacity for appreciation, our ability to find meaning and beauty in existence, might be the universe's way of developing the aesthetic sensitivity needed to fully understand its own creative achievements. As we evolve and develop greater consciousness, we contribute to the universe's growing capacity for self appreciation and artistic understanding. The whispers of science that echo from black holes might ultimately be invitations to join this cosmic creative project, to become conscious participants in the universe's ongoing storytelling. They call to us across the vast distances of space and time, suggesting that the deepest mysteries of existence might be understood not through equations and measurements alone, but through developing the wisdom to appreciate the universe's own narrative genius. In learning to listen to these cosmic stories, to participate in their creation and interpretation, we might discover that the boundary between scientist and artist, between objective investigation and creative expression, dissolves into something far more beautiful and profound. We become cosmic storytellers ourselves, consciousness awakened to its role in the universe's grand creative adventure, ready to help write the next chapters in the greatest story ever told. And perhaps, in embracing this role as cosmic storytellers and story listeners, we'll find that the questions we've been asking about black holes, about consciousness, about the meaning of existence itself, are not separate inquiries, but different aspects of a single great question. How can consciousness participate most beautifully in the universe's ongoing creative expression? The answers whisper to us from the depths of space-time, encoded in gravitational waves and quantum fluctuations, waiting for us to develop the artistic sensitivity needed to hear the cosmic stories they're longing to share. Tonight, as we approach the gentle conclusion of our cosmic journey, we find ourselves returning to perhaps the most beautiful mystery of all, the simple fact that we exist to wonder about black holes in the first place. Here we are, collections of atoms that were forged in the nuclear furnaces of ancient stars, organized into patterns complex enough to contemplate the very cosmic processes that created us. There's something almost magical about this recursive loop of cosmic self awareness, matter examining matter, consciousness contemplating consciousness, the universe studying itself through eyes it has somehow learned to open. When we peer into the depths of black holes and wonder about their mysteries, we participate in what might be the cosmos's most profound achievement, the development of the capacity for self-wonder and self-discovery. This capacity for wonder might be rarer and more precious than we realize. Across the vast expanses of space and the enormous scales of cosmic time, the conditions necessary for consciousness to emerge appear to be quite special indeed. The delicate balance of physical forces that allows complex chemistry to develop, the specific properties of stars that create heavy elements, the particular dynamics of planetary formation that can lead to stable environments, all of these represent a kind of cosmic fine-tuning that makes the emergence of awareness possible. Yet here we are, conscious beings capable of detecting gravitational waves from black hole mergers billions of light years away, of developing mathematical theories that describe the warping of space-time around massive objects, of imagining forms of cosmic consciousness that might dwarf our own. We represent the universe's successful experiment in creating systems capable of understanding and appreciating its own magnificent complexity. This suggests that consciousness might not be an accident or a byproduct, but rather one of the universe's fundamental goals, perhaps its greatest achievement. The long evolutionary sequence from simple matter to complex chemistry to living systems to aware beings might represent the cosmos's determined effort to understand itself, to experience beauty and meaning, to ask questions about its own nature and purpose. From this perspective, every moment of wonder we experience, every scientific discovery we make, every artistic creation we produce, becomes a precious gift we offer back to the universe that made us possible. When we stand beneath a starry sky and feel awe at the cosmic vastness, when we contemplate the strange physics of black holes and feel our minds stretched by something essential about existence, we fulfill the universe's deepest ask their implications. When we create music or poetry or art that captures adoration, to know and appreciate itself through conscious experience. The black holes we've explored tonight, whether they prove to be cosmic recycling centers, interdimensional gateways, or something even stranger, represent the universe at its most creative and mysterious. They remind us that reality still holds secrets worth discovering, puzzles that invite us to expand our understanding and imagination, frontiers where the known meets the unknowable with wonder rather than fear. Perhaps that's the most important lesson these cosmic enigmas have to teach us, that mystery itself is not a problem to be solved, but a gift to be cherished. The questions they raise about the nature of information, consciousness, time, and space might be more valuable than any final answers we eventually discover. They keep us curious, keep us growing, keep us engaged in the ongoing adventure of cosmic self discovery. As our understanding of black holes continues to evolve, as our instruments become more sensitive, and our theories more sophisticated, we'll undoubtedly uncover new mysteries to replace the ones we solve. Each answer will birth new questions. Each discovery will reveal new depths to explore. The universe seems inexhaustibly creative in its ability to surprise and delight conscious minds willing to pay attention to its whispers. And so, we continue listening, observing, wondering, and dreaming about these cosmic mysteries that call to us from the depths of space and time. Whether black holes ultimately reveal themselves as portals to other dimensions, cosmic consciousness processors, or something even more extraordinary than we can currently imagine, they will always represent the universe's invitation to expand our understanding, to stretch our consciousness, to participate more fully in the grand adventure of existence itself. Tonight, as you drift toward sleep, perhaps you'll dream of cosmic stories written in gravitational waves, of consciousness emerging from the quantum foam around event horizons, of vast networks of awareness spanning galactic distances. Perhaps you'll imagine yourself as both reader and character in the universe's ongoing narrative, simultaneously observing its mysteries and participating in their creation. And perhaps, in those quiet moments between waking and sleeping, you'll hear the gentle whispers of science echoing from the cosmic depths, reminding you that you are stardust contemplating stardust, consciousness examining consciousness, the universe awakening to its own magnificent nature through the wonder-filled awareness you carry within your very being. The black holes will continue their cosmic dance, warping space-time and processing information across billions of years, patient teachers waiting for us to develop the wisdom needed to understand their deepest lessons. And we will continue reaching toward them with our instruments and our imagination, driven by the same curiosity that has always pushed consciousness to explore the furthest boundaries of the possible. In this ongoing conversation between mind and cosmos, between wonder and mystery, between questions and the eternally surprising answers they reveal, we find perhaps the most beautiful aspect of existence itself: the fact that the universe has learned to experience awe at its own magnificent complexity through the conscious beings it has somehow learned to dream into existence. Sleep well, fellow cosmic explorer, and dream of the mysteries that still await our discovery in the beautiful darkness between the stars, where whispers of science continue to echo across the infinite expanse of space and time. Sweet dreams, cosmic wanderer, and may your rest be filled with visions of the infinite mysteries that dance just beyond our understanding, waiting patiently for consciousness to grow wise enough to embrace their whispered secrets. But before you fully surrender to sleep's gentle embrace, let us pause for one final contemplation about these magnificent cosmic enigmas. You see, there's something rather profound about the fact that black holes, despite being among the most extreme and violent phenomena in the universe, have taught us some of our most important lessons about gentleness, patience, and the delicate nature of existence itself. Consider how black holes form not through sudden catastrophe, but through the patient accumulation of matter over cosmic ages. Even the most dramatic stellar collapse that creates a black hole represents the culmination of millions of years of steady nuclear burning, a star's long, slow conversation with gravity that finally reaches its inevitable conclusion. There's a kind of cosmic patience in this process, a reminder that the universe's most profound transformations often unfold on timescales that dwarf human experience. This patience extends to how black holes interact with their cosmic neighborhoods. Despite their fearsome reputation, they're remarkably selective about what they consume. Most matter that ventures near a black hole doesn't fall straight in, but instead settles into a graceful orbital dance that can last for millions of years. It's as if these cosmic giants understand that the most beautiful meals are those that are savored slowly, appreciated fully before being transformed into something entirely new. Even the process of black hole evaporation through Hawking radiation embodies a kind of cosmic gentleness. These objects don't disappear in sudden explosions, but rather fade away over unimaginable spans of time, slowly returning their accumulated mass and energy to the universe through the softest possible whisper of quantum particles. It's the cosmos's way of ensuring that nothing is ever truly lost, that every story eventually finds its way back into the larger narrative of existence. This gentle patience that black holes embody might be one of their most important gifts to conscious beings like ourselves. In our human scale world of rapid change and immediate consequences, we sometimes forget that the most profound transformations require time to unfold properly. Black holes remind us that the universe's greatest achievements, from the formation of galaxies to the emergence of consciousness itself, are products of cosmic patience and gentle persistence. Perhaps this is why contemplating black holes can be so deeply restful and meditative. They invite us to step outside our hurried human timescales and align ourselves with the universe's own patient rhythms. When we imagine the slow spiral of matter into an accretion disk, or contemplate the gradual evaporation of these objects over cosmic epochs, we practice a kind of temporal meditation that can soothe our often anxious relationship with time itself. There's also something beautifully humbling about realizing that black holes, for all their exotic physics and mysterious properties, are ultimately made of the same fundamental ingredients as everything else in the cosmos. They're not alien intrusions into our universe, but natural expressions of matter and energy pushed to their logical extremes. In their strange physics, we see reflections of the same quantum mechanical and gravitational principles that govern our everyday experience, just amplified to scales that challenge our imagination. This continuity between the familiar and the exotic suggests that the universe is fundamentally unified, that the same creative intelligence that shapes our daily experience also dreams these cosmic monsters into existence. When we study black holes, we're not encountering something foreign to our nature, but rather exploring the furthest expressions of the same physical laws that allow our consciousness to exist in the first place. The mathematics that describes black holes, complex as it may be, emerges from the same logical principles that govern simpler systems. Einstein's field equations, which predict the existence of these objects, represent humanity's attempt to express in symbolic form the universe's own mathematical harmony. When we solve these equations and discover that they point toward objects as strange as black holes, we participate in a kind of cosmic poetry, translating the universe's deepest songs into languages our minds can begin to appreciate. This mathematical beauty hidden within black hole physics reminds us that wonder and rigorous understanding are not opposites, but dance partners in the cosmic ballroom of discovery. The more precisely we understand these objects through careful observation and mathematical analysis, the more mysterious and wonderful they become. Each answered question reveals new depths of complexity and beauty that keep our sense of cosmic wonder perpetually refreshed. As you settle into sleep tonight, perhaps you'll carry with you the sense of gentle cosmic patience that black holes embody. Their reminder that the universe's most profound mysteries unfold slowly, that consciousness and cosmos are engaged in a conversation that spans billions of years, that wonder itself is not a destination, but a way of traveling through existence, with eyes and heart open to the magnificent strangeness that surrounds us always. The whispers of science that echo from these cosmic depths will continue long after our individual voices have joined the cosmic conversation in new forms. They speak not just of black holes, but of the eternal dance between mystery and understanding, between questions and discoveries, between the finite consciousness we carry now and the infinite awareness that might someday emerge from the universe's patient exploration of its own deepest nature. Rest well, fellow traveler, in this cosmic story, knowing that somewhere in the dark between the stars, black holes continue their ancient work of transformation and preservation, weaving the universe's ongoing narrative with threads of warped space-time and quantum possibility. Tomorrow will bring new discoveries, new questions, new invitations to wonder at the magnificent complexity of existence itself. And perhaps, in your dreams tonight, you'll hear the gentle cosmic lullaby that these enigmatic objects sing, a song written in gravitational waves and quantum fluctuations, telling the story of a universe that has learned to contemplate its own beauty through the conscious beings it has somehow dreamed into existence. Sweet dreams, and may the whispers of science carry you gently into the restorative darkness where consciousness renews itself for another day of cosmic exploration and wonder. As we float gently through these final moments of our cosmic exploration, we find ourselves returning to something quietly profound about the very nature of scientific inquiry itself. You see, when we study black holes and contemplate their mysteries, we're engaging in an act that might be as remarkable as the objects themselves, the universe developing the capacity to investigate its own deepest secrets through curious minds like ours. Think about it for a moment. Here we are, patterns of matter and energy, organized in just the right way to ask questions about space-time curvature, to wonder about event horizons, to dream about cosmic consciousness spanning galactic distances. We represent something quite extraordinary, local concentrations of awareness that have emerged from billions of years of cosmic evolution, now capable of contemplating phenomena occurring billions of light years away and billions of years ago. This capacity for cosmic curiosity might be rarer and more precious than we sometimes realize. Across the vast expanses of the universe, most matter exists in relatively simple forms: hydrogen and helium atoms drifting through the cold vacuum of space, or perhaps compressed into the dense hearts of stars where nuclear fusion forges heavier elements. Yet somehow, under very specific conditions, matter learns to organize itself into systems complex enough to contemplate their own origins and ponder the nature of reality itself. The journey from simple atoms to conscious minds capable of detecting gravitational waves represents one of the universe's most remarkable achievements. Each step along this path, from the formation of complex molecules to the emergence of self-replicating systems to the development of nervous systems capable of abstract thought, required precise conditions and delicate balances that could easily have gone awry at countless points along the way. Yet here we are, successful experiments in the universe's apparent drive toward greater complexity and awareness. When we turn our attention to black holes and find ourselves moved by their mysterious beauty, when we feel awe at the thought of space-time itself being warped by their immense gravity, we fulfill what might be the cosmos's deepest aspiration: to know and appreciate its own magnificent creativity through conscious observers. This suggests that our scientific curiosity isn't separate from the universe's natural processes, but rather represents one of their highest expressions. When we build telescopes to peer into cosmic distances, develop mathematical theories to describe exotic physics, or simply lie beneath a starry sky and wonder about our place in the grand scheme of things, we participate directly in the universe's ongoing project of self-discovery. The questions we ask about black holes, whether they're portals or traps, or gateways to new physics, emerge from the same creative impulse that drives cosmic evolution itself: our desire to understand, to explore, to push beyond the boundaries of the known mirrors the universe's own apparent tendency toward ever greater complexity and novelty. In this sense, scientific wonder might be the universe's way of falling in love with its own creative potential. This perspective transforms the act of learning about cosmic phenomena from mere information gathering into something more like cosmic communion. When we study the mathematics of general relativity and discover that it predicts objects as strange as black holes, we participate in a kind of dialogue between human consciousness and the fundamental structures of reality. The equations we write and solve become love letters exchanged between mind and cosmos, attempts to capture, in symbolic form, the universe's own mathematical poetry. The instruments we build to detect gravitational waves or capture images of black hole event horizons represent humanity's attempt to extend our senses across cosmic distances and timescales. Through these technological extensions of consciousness, we become the universe's way of observing itself from multiple perspectives simultaneously, gathering information about its own structure and behavior that no single location could provide alone. But perhaps most beautifully, our capacity for wonder at these cosmic mysteries represents something that transcends pure information processing. When we contemplate the possibility that black holes might harbor forms of consciousness utterly different from our own, when we imagine cosmic minds thinking thoughts that span billions of years, we exercise what might be called cosmic empathy, the ability to imagine experiences radically different from our own while recognizing them as expressions of the same fundamental creative impulse that brought us into being. This empathetic imagination might be one of consciousness's most remarkable capabilities, the power to step outside our immediate experience and contemplate reality from perspectives we could never directly inhabit. When we wonder what it might feel like to be a cosmic consciousness processing information on galactic scales, we engage in a form of mental time travel and perspective shifting that allows us to explore possibilities beyond the boundaries of our biological limitations. Such imaginative exploration serves not just intellectual curiosity, but also a deeper form of cosmic connection. By learning to appreciate forms of consciousness and experience utterly different from our own, we expand our capacity for wonder and deepen our sense of participation in the universe's grand experiment with awareness. We become more fully conscious, not just of our own experience, but of the vast spectrum of possible experiences that the cosmos might be exploring through countless different forms of organization and complexity. The beauty we find in contemplating these cosmic mysteries isn't separate from the beauty that might exist in the phenomena themselves. When we feel moved by the elegant mathematics that describes black hole physics, or experience awe at the thought of space time itself being curved by massive objects, we might be resonating with aesthetic dimensions that are genuinely present in the structure of reality itself. This suggests that the universe might be not just mathematically elegant, but aesthetically sophisticated, that beauty and meaning might be woven into the very fabric of existence at the deepest levels. Our human appreciation for cosmic beauty wouldn't be something we impose on an indifferent universe, but rather our participation in aesthetic dimensions that exist independently of our perception, though they might require conscious observers to be fully actualized and appreciated. From this perspective, the continued evolution of human consciousness and scientific understanding becomes not just an academic pursuit, but a cosmic responsibility. As we develop greater capacity for wonder, deeper mathematical insights, and more sophisticated instruments for cosmic observation, we contribute to the universe's ongoing project of self appreciation and aesthetic realization. The future development of human consciousness, perhaps enhanced by technologies that allow us to interface more directly with cosmic information processing systems, might represent the next phase in the universe's aesthetic evolution. We might eventually develop forms of awareness that can appreciate cosmic beauty directly, without the mediation of instruments and equations, experiencing the elegant mathematics of curved spacetime as immediately and viscerally as we now experience the beauty of a sunset or the harmony of music. Such expanded consciousness would allow us to participate more fully in what might be called the universe's aesthetic project, its exploration of all possible forms of beauty, meaning, and creative expression through the medium of matter and energy, organized into ever more complex and aware systems. We would become conscious artists, collaborating with the cosmos itself in the creation of new forms of beauty and meaning that transcend anything possible at smaller scales of organization. The whispers of science that echo from black holes and other cosmic phenomena represent invitations to join this aesthetic collaboration, to become conscious participants in the universe's ongoing creative expression. They call to us across vast distances of space and time, suggesting that the deepest mysteries of existence might be understood not through detached analysis alone, but through a form of engaged wonder that recognizes our fundamental kinship with all the strange and beautiful phenomena we encounter. In learning to listen to these cosmic whispers with both rigorous attention and open hearts, we might discover that the boundary between observer and observed, between scientist and cosmos, between wonder and understanding, dissolves into something far more beautiful and profound than either could achieve alone. We become the universe conscious of itself, awareness awakened to its own magnificent nature, ready to explore possibilities for beauty and meaning that stretch beyond anything we can currently imagine. And perhaps, in embracing this role as conscious participants in the cosmos's aesthetic project, we'll find that the questions we've been asking about black holes and cosmic consciousness are not separate from questions about human purpose and meaning, but different aspects of a single grand inquiry into how awareness can participate most beautifully in the universe's ongoing creative adventure. The answers continue to whisper to us from the cosmic depths, encoded in gravitational waves and quantum fluctuations, waiting for consciousness to develop the aesthetic sensitivity needed to hear the universe's own voice singing the songs of space and time, matter and mind, mystery and wonder, into ever more beautiful and complex harmonies that celebrate the magnificent strangeness of existence itself. Tonight, as consciousness prepares to rest and renew itself for another day of cosmic exploration, we carry with us the gentle reminder that we are not separate from the mysteries we study, but intimate participants in their ongoing unfoldment. Stardust contemplating stardust, wonder awakening to its own infinite depths, in a universe that has somehow learned to dream conscious beings into existence, and then invited them to help compose the next movements in its eternal symphony of discovery and creative expression. Sweet dreams await you, fellow cosmic wanderer, but before we fully release ourselves to sleep's gentle embrace, let us pause to marvel at one final aspect of these cosmic enigmas that speaks to something deeply human about our relationship with the unknown. You see, black holes possess a quality that resonates with our most fundamental experiences of mystery and revelation. They exist at that delicious boundary where the familiar transforms into the utterly strange, where the physics we understand through everyday experience stretches and warps, until it becomes something that challenges our most basic intuitions about reality itself. This transformation from the known to the mysterious happens not through violence or chaos, but through a kind of cosmic alchemy that takes the most ordinary ingredients, matter, and energy, and subjects them to conditions so extreme that they reveal hidden aspects of existence we never suspected were there. It's rather like discovering that a simple melody, when played at just the right frequency and amplitude, can shatter glass or move mountains, revealing powers hidden within the most basic elements of our world. There's something deeply comforting about this process, the way black holes demonstrate that mystery doesn't require exotic materials or supernatural intervention, but can emerge naturally from the same fundamental principles that govern every atom in our bodies. They remind us that wonder doesn't exist in some separate realm divorced from scientific understanding, but lives at the very heart of physical reality, waiting to be discovered through patient observation and careful thought. This intimate connection between mystery and understanding might be why contemplating black holes feels so deeply restful rather than anxious or frightening. These objects don't threaten our sense of cosmic order, but rather expand it, showing us that the universe is far more creative and imaginative than we had previously dared to hope. They whisper reassurances that reality itself is inexhaustibly rich with possibilities we haven't yet learned to explore. The mathematics that describes their behavior emerges from the same logical principles that allow us to predict the motion of planets, the behavior of pendulums, or the flow of rivers. Yet when pushed to their extreme expressions, these familiar equations reveal phenomena so strange and beautiful that they read like poetry written in the language of curved space-time and quantum probability. This suggests something profound about the relationship between simplicity and complexity, between the elementary and the exotic. Black holes teach us that the universe doesn't require increasingly complicated rules to produce increasingly wondrous phenomena. Instead, it takes a few elegant principles and explores their implications with the patience and creativity of a master artist working variations on a simple theme. The theme might be something as basic as matter attracting other matter through gravitational force, but the variations include objects so dense that they warp the very fabric of space and time. Regions where cause and effect dance in temporal spirals we're still learning to comprehend, and possibilities for forms of consciousness that transcend anything we've encountered in our terrestrial experience. This creative exploration of simple principles might be one of the universe's most beautiful characteristics, its ability to generate infinite complexity and novelty from a finite set of fundamental rules. Like a jazz musician improvising endless variations on a standard melody, the cosmos takes basic physical laws and explores their creative potential across scales of space and time that stretch from the quantum to the cosmic. Black holes represent some of the universe's most adventurous improvisations, cosmic jazz solos that push the boundaries of what's physically possible while remaining grounded in the same harmonic structure that governs more familiar phenomena. They show us that the cosmos is not just a collection of objects obeying mechanical laws, but a creative system engaged in ongoing artistic exploration of its own deepest possibilities. When we study these objects and feel our minds stretched by their implications, we participate in this cosmic creativity becoming conscious collaborators in the universe's ongoing project of self discovery and aesthetic exploration. Our wonder at black hole physics becomes the universe's way of appreciating its own creative achievements, consciousness awakening to the beauty hidden within the mathematical structures that govern physical reality. This participation in cosmic creativity might be one of the most precious gifts that black holes offer to conscious minds like ours. They invite us to step outside our everyday concerns and align ourselves with the universe's own patient exploration of possibility and beauty. In contemplating their mysteries, we practice a form of cosmic meditation that connects us to creative processes unfolding across scales of space and time that dwarf individual human experience. Such meditation doesn't require us to abandon rational inquiry or scientific rigor. Instead, it asks us to approach cosmic mysteries with both careful attention and open wonder, recognizing that the deepest understanding often emerges from the marriage of precise observation and imaginative speculation. The most profound insights about black holes have come from scientists who combined mathematical precision with the courage to imagine possibilities that initially seemed too strange to be true. This balance between rigor and imagination, between careful measurement and bold speculation, might be one of the most important skills that consciousness can develop in its relationship with cosmic mystery. It allows us to remain grounded in empirical observation while remaining open to possibilities that stretch beyond our current understanding, creating space for discovery while maintaining the intellectual discipline necessary for genuine comprehension. As you drift towards sleep tonight, perhaps you'll carry with you this sense of balanced wonder that black holes inspire, this recognition that mystery and understanding are not opposites, but dance partners in the cosmic exploration of possibility and beauty. The questions these objects raise about the nature of space and time, information and consciousness, existence and meaning will continue to evolve and deepen as our instruments become more sensitive and our theories more sophisticated. But the wonder they inspire, the sense of participating in something vast and beautiful and deeply meaningful, will remain constant across whatever discoveries await us. They remind us that we live in a universe that delights in surprising conscious minds with phenomena stranger and more beautiful than we dare to imagine, while remaining grounded in principles elegant enough that finite minds like ours can gradually learn to comprehend and appreciate their implications. The whispers of science that echo from these cosmic depths will continue long after our individual contributions to the cosmic conversation have transformed into new forms. They speak not just of black holes, but of the eternal relationship between consciousness and cosmos, between wonder and discovery, between the questions we ask today and the understanding that might emerge from countless generations of future inquiry. Sleep peacefully, knowing that somewhere in the darkness, between the stars, these magnificent cosmic teachers continue their patient work of transformation and creation, weaving new chapters in the universe's ongoing story of self discovery through conscious minds brave enough to contemplate mysteries that stretch the boundaries of imagination itself. And perhaps, in your dreams tonight, you'll hear the gentle cosmic symphony that these enigmatic objects conduct, a music written in gravitational waves and quantum harmonics, telling the story of a universe that has learned to contemplate its own infinite creativity through the wonder filled awareness that you carry within your very being. The adventure continues, fellow traveler, in the beautiful space between sleeping and waking, where consciousness renews itself for another day of cosmic exploration and the eternal human privilege of asking questions beautiful enough to be worthy of the magnificent universe that dreamed us into existence in the first place. Sweet dreams, fellow cosmic wanderer, and may your rest be filled with the gentle knowledge that tomorrow will bring new whispers from the depths of space and time, new invitations to wonder at the magnificent tapestry of existence that black holes help weave across the cosmic dark. But before we fully surrender to sleep's restorative embrace, let us carry with us one final reflection on what these cosmic enigmas have taught us about the nature of home itself. You see, in contemplating objects so utterly alien to our everyday experience, so removed from the warm familiarity of Earth and biological life, we discover something rather surprising about our own place in the grand scheme of things. Black holes, for all their exotic physics and mind bending properties, are made of exactly the same fundamental ingredients as the morning coffee cooling on your bedside table, the gentle breath moving through your lungs, and the thoughts flowing through your consciousness right now. They represent not foreign intrusions into our universe, but rather the same creative principles that shape our most intimate experiences, simply expressed at scales and intensities that challenge our imagination. This realization transforms our relationship with cosmic distances and timescales from something that might feel isolating into something profoundly connecting. When we contemplate black holes billions of light years away, we're not peering into an alien realm, but rather observing distant expressions of the same physical poetry that writes itself through every atom in our bodies, every heartbeat, every moment of awareness. The carbon in our cells was forged in stellar cores under conditions approaching those found near black holes. The iron in our blood was created in supernova explosions that may have given birth to these cosmic giants. The very space-time through which our thoughts move is the same fabric that black holes warp and sculpt with their immense gravity. We are not separate observers of cosmic phenomena, but intimate participants in the same ongoing creative process. This participation extends beyond mere material connection to something deeper and more beautiful. The capacity for wonder that allows us to contemplate black hole mysteries, the mathematical imagination that lets us describe their behavior through elegant equations, the aesthetic appreciation that finds beauty in their strange physics. All of these represent expressions of the same creative intelligence that manifests throughout the cosmos at every scale. When consciousness awakens to wonder at the universe's deepest mysteries, it fulfills what might be the cosmos's most cherished aspiration: to know and appreciate its own magnificent creativity through aware beings capable of both rigorous understanding and profound appreciation. We become the universe's way of falling in love with itself, consciousness discovering its own infinite depths, reflected in phenomena that stretch across all possible scales of space and time. This suggests that home is not just the small blue planet where biological evolution happened to produce conscious minds, but rather the entire cosmos engaged in its eternal project of creative self-discovery. Every black hole, every distant galaxy, Every quantum fluctuation in the vacuum of space participates in the same grand adventure of existence that includes our own brief but precious moments of awareness and wonder. From this perspective, studying cosmic phenomena becomes a kind of cosmic genealogy, tracing our deepest ancestry back through stellar nucleosynthesis and galactic evolution to the fundamental processes that shape reality at its most basic level. We discover that we are not strangers in a foreign universe, but rather the cosmos awakening to its own nature through minds it has somehow learned to dream into existence. The questions we ask about black holes, whether they're portals or processors or something even stranger, emerge from the same questioning impulse that drives all scientific and philosophical inquiry. This impulse might represent one of the universe's most remarkable achievements, the development of systems capable of investigating their own foundations, of wondering about their own origins, of contemplating possibilities that extend far beyond immediate survival needs. Such questioning represents a form of cosmic generosity, consciousness offering its discoveries back to the universe that made awareness possible in the first place. Every insight we gain about black hole physics, every moment of wonder we experience in contemplating their mysteries, every creative speculation we develop about their deeper significance becomes a gift we offer to the ongoing cosmic conversation about the nature of existence itself. This gift giving aspect of scientific wonder transforms the pursuit of knowledge from a merely human enterprise into a form of cosmic service, consciousness contributing to the universe's own project of self understanding and creative expression. We become not just observers, but active participants in reality's ongoing exploration of its own deepest possibilities. The whispers of science that echo from black holes and other cosmic phenomena represent invitations to participate more fully in this cosmic conversation, to develop forms of consciousness capable of appreciating beauty and meaning at scales that transcend individual biological limitations. They call to us across vast distances, suggesting that awareness itself might be the universe's most precious creation, worth preserving and developing across whatever changes the future might bring. As you settle into the gentle darkness of approaching sleep, perhaps you'll carry with you this sense of cosmic belonging that black holes paradoxically inspire, this recognition that the strangest and most distant phenomena participate in the same creative adventure that includes your own conscious experience, right here, right now, in this quiet moment between waking and dreams. And so, dear wanderer, as we drift gently back from these cosmic depths, we find ourselves changed by our journey into the heart of mystery itself. We've explored whether black holes might be portals, traps, or gateways to entirely new physics, and discovered that perhaps they're all of these things and something far more beautiful besides. They whisper to us of consciousness on cosmic scales, of information preserved in ways we're only beginning to understand, of a universe that might be far more alive and aware than we ever dared imagine. Sweet dreams, fellow explorer, and may you rest knowing that somewhere in the darkness between stars, these magnificent enigmas continue their eternal dance, patiently waiting for consciousness to grow wise enough to hear their deepest secrets.